So welcome to the Unit 2, Module 1 quiz review. Let's get started. So first thing we had was Lesson 1, looping. This is probably one of the challenging pieces of code that we've dealt with so far, in that it does require several pieces. So this was the basic structure of a for loop, just to remind you. You will be responsible for some of this vocabulary. You do have to know what they mean. We have the loop counter. That's just a variable. It can be any variable whatsoever. We have the range. We have to have that in order to do our for loop. We have the for command and the in command. Both of those have to be there. And don't forget the colon. So this top line of the for loop, you have to really memorize the structure of that. It's the word for, a variable, the in command, the range. Remember, the range does not include the last number. So for a range of 1 through 9, it's 1, 2, 3, 4, 5, 6, 7, 8. It's not including the 9. Then we have our body. Must be indented. Anything that is not indented is not part of the loop body. Let me say that again. Anything that is not indented is not part of the loop body. As soon as you stop indenting, you end the loop. So this line down here is not indented, so it's not part of the loop body. This is worth restating. Indentation is very important in Python. Everything is based upon that structure. If it's not indented properly, you will get an indentation error. So for example, if you don't indent every part of your loop body, let's say you have 5 lines in your loop body, you indent the first 2, don't indent the third, and then go ahead and indent the last one, well, the last 2. What happens is Python will look at those last 2 lines saying, well, they're not supposed to be indented. The loop ended. It ended on the first line that you didn't indent. That's the end of the loop body. The first line that you failed to indent is the end of the loop body. So if you're not using proper indentation, then it's going to give you an error, indentation error. The times that error comes up the most is when people don't use tabs, instead they use spaces. If you're just hitting the space bar, it's very easy to do 4 spaces instead of 5 spaces. So the simple fix for that is to always use the tab key. That way you know everything is lined up. If you get that error, the easy way to fix it is just bring everything back to the side and re-tab everything out. Make sure everything is lined up. So always double check that indentation. There definitely will be a question about indentation on the quiz. In this example, the main focus was another vocabulary word. It's called refactoring code, where you take a large section of code, namely this piece over here, and shrinking it down to a smaller section of code. So anytime we take repeated code, commands that are essentially the same command over and over again, and make it into something smaller, that's refactoring the code. So in this case, the for loop refactors the code for us, and uses the loop counter measure in order to take the place of individual commands. So we look at this, it's pretty easy to see when code needs to be refactored. We have 1, 1.5, 2, 2.5, 3, 3.5. There's some type of pattern that's being followed. Other than that, the command is identical. Drum, drum 2, drum, drum 2, same track all the way through. So once you see that there is some type of pattern, you want to try to take that code and make it smaller, refactor it. The purpose of refactoring code is, one, yes, it makes it shorter, less to type, makes it cleaner, but if you need to change something, you have much less to change. If I decided that I wanted this one to be on track 1, the other one to be on track 2, in the refactored code, all I have to do is change one number. Change that 1 to a 2. In the unrefactored code, for lack of a better term, or the big code, the messy code, I'd have to go through and change every single one of these lines for drum 2. I could accidentally miss one, cause an error, or at least a logical error, and get something that I don't intend to. So it's always better to take that code and make it smaller. Yes, sometimes you have to be creative. Yes, sometimes it's harder to think your way through that solution. But in the long run, it's going to make finding mistakes, it's going to make changing your code a lot easier. I don't think this actual vocabulary word is on the quiz. I thought about putting it on, but I thought it would be a little bit abstract because it's not really related to an example, but it's the control flow. Essentially what happens here is you're changing the flow of the computer program. Up till us learning the for loop, the control flow was one step at a time, one line at a time, line after line after line after line. Once we introduce the for loop, we've now changed the flow of the program. It sees the command for the for loop. It knows it has to do those commands underneath the for loop a certain number of times. It goes through and repeats those commands over and over again. It goes back up to the final check to make sure we're done with the for loop. If we're done with the for loop, then it skips all those commands and moves on to the next command. So we're really modifying the order in which the program flows. There will be other commands that we're going to learn that control the flow of the computer. So this all falls into the same category of control flow statements. So here's an example of how that flow works out. So we start with the loop counter at 1. Then the loop counter becomes a 2. Loop counter becomes a 3. Loop counter becomes a 4. Now this last part's important. Watch. Once it finishes this, it goes back up to the top again. Checks to see that it's at the end of the range, then goes back down to here. That's the actual flow of a for loop. We also talked about incrementing and decrementing in a odd way that is different than the way you do it in math class. We talked about using measure equals measure plus 1. So really, but it's not really an equal sign here. It's really an assignment, and it says, take the value that's in measure, add 1 to it, put it back in measure. And computer scientists, being computer scientists, don't like to repeat things. So by having to type the word measure twice, it's annoying. They like to be practical, and you're going to find that they create things to make their lives easier, even if it doesn't look normal to most people. So what they said was, well, really, the two important symbols in here are the plus and the equals. That's really all that's important, is the plus, the equals. So we're going to create a command that means this, but with less typing. So they came up with plus equals. So in here, it's measure plus equals 1, and it means take the value of measure, increment it by 1, and store it back inside a measure. We could do measure plus equals 5, and that would be take the value of measure, increment it by 5, and store it back in measure. In addition, we also have minus equals. It does the same thing, only by subtraction. Take the value that's in measure, subtract 1, store it back in measure. So we have to be careful of our language here. Technically, we don't want to say this is an equals, even though it's a symbol is an equals, but it's really plus a sign 1. Makes it a little bit easier to understand if you're saying a sign every time you see an equal sign. Once you get used to it, it's not a big deal. But as you're making that transition from mathematics to computer science, we have these oddities, like the equal sign, not really meaning the same thing all the time. You could also do multiplication as well, but that's not on the quiz. You could do times equals, divide equals, mod equals, all those. They're called unary operators. Unary operators exist in many other languages as well. In lesson 2, we talked about using the same types of for loops, only adding special sound effects to it. as opposed to using just music, the set media command. So we had a sound that we took a look at, and we saw the effect of it, and it ended up having this effect of bouncing the sound up and down throughout the measure. So we have here, down here, this track as our loop counter, and they did some interesting math here to make the pan left and the pan right work out. So by using this one loop down here, they were able to create 3 different pans, left, middle, and right, 3 different pan effects just by using this one loop command. And the way they did is they took that loop counter and used it twice inside the command. The first time they used it is by picking the track. So when our range is 1, track is 1. So we're going to do it in the first track. Then our calculation based upon track 1 gives us our first pan amount, which I think was like -100. Then when we do track 2, this track value calculates the next pan amount, which I think was like 33. Then we do our track 3, which is our next pan amount, which I think was like another, well, I think it was -33, then +33, and then finally +100. So by going through all 4 of those tracks, they're able to get in there 4 different pans, 2 on the left, 2 on the right, and do those calculations. So the formula is pretty much made up by whoever coded it. It doesn't have to be that formula. You can make up any type of formula you want, and that's what we did in our example. You guys had to come up with your own way of creating effects. And some of you created formulas, some of you just use the values that were there, and that's all okay. It really is going to depend upon what kind of sound that you want to appreciate when you're getting closer and closer to your final project. Again, as we do these, you should be playing with different things. And that's the beauty of refactoring your code, is it makes it very easy to play with different things as opposed to having to change 50 different lines. You really only have to change one line. Look at the great effect that we have here, is by just modifying a little bit of code here, maybe changing the 200 to a 150, maybe modifying this so it's affecting some other type of effect. Maybe we're going to add in distortion as well. Maybe we're going to affect gain as well. By adding in those different effects, we can end up getting a much different sound very quickly. So by setting another example, we looked at a simpler example. We looked at the effect of modifying the gain. And in this case, by setting that gain so it's measure and measure for our start and ending envelope, the sound has the effect of this spike effect where it goes up and down. And it kind of gets that wah-wah sound where the sound goes up and then starts really loud and then cuts off to 0 and then goes back up to really loud and then cuts off to 0 and really loud. And that had a really interesting effect. Just for fun, we'll just play that again. Maybe we will. Here we go. Again, we can create effects that you can't do any other way. To create this effect, you'd have to have, what, 18 different lines of code to make that happen, and you'd have to do measure 1 to measure 2, measure 2 to measure 3, measure 3 to measure... It'd be ridiculous. And if you decided to change something, maybe you're going to change your gain from -60 to -40, you'd have to go ahead and change all 17 lines of code. That'd be horrible. You wouldn't be able to experiment with that. It wouldn't be very fun. But this, you could go ahead and modify that gain, come up with all different kinds of things. Again, add in other effects, like maybe you're going to add in a distortion effect on the opposite side of it. So maybe when it gets quiet, you have a distortion, picking and choosing what you want there. Really just 2 lessons for here, but there's a lot, especially in that lesson 1. So I would go back, look at lesson 1, click on the notes, go back through, study those vocabulary words, make sure you're ready for the quiz. Maybe play back, there's a video in there that we use for the cyber class. Play that video back, go through the information again, whichever method works for you, either reading over the notes or playing the video back. But either way, you do have certain things that you have to study. Good luck on the quiz, and remember, never stop coding.